next up, I'd like to bring Derek Johnson up. There you are. Derek runs our engineering team, and we've got Dr. Rusheng Zhang on Zoom. Yes, okay. Dr. Zhang is a research scientist at Mcity and one of the principal architects of Mcity. And not to steal all your thunder, but we're going to announce the open sourcing of something here for you today that hopefully you can use. Derek, would you like to come on up and talk about it? All right, thanks.
All right, as Greg said, I'm Derek Johnson. I'm the principal engineer here at Mcity, and I have the pleasure today of talking about the near miss project. So we're going to try and recover some time here. So that's okay. All right, we'll go with the original plan then. So what you're looking at right here is a bit of history. As Greg said, I'm going to talk through some of the benefits of the near miss project, and I'm going to hand it off to the architect, Rusheng Zhang. This story here highlights the funding and the history of the near miss project. On the left, we have the Smart Intersections project, which was a significant investment in research and infrastructure that followed on with ACE 2.0, where we kind of did away with the DSRC and brought in more cellular technologies for C-V2X. Again, a significant investment in infrastructure and research. And now here we have the near miss project of the city of Ann Arbor. And I think this is a wonderful story because it's good investment followed by affordable benefit to society. And I'm going to share some of those benefits with you today. So what exactly does the near miss project do? It uses existing infrastructure cameras to observe intersections and detect where cars are going and where people are going, vulnerable road users, et cetera. And we can recreate those scenarios, and we can do it in almost near time. So that's what you're looking at right here. Just cars that are moving through various intersections throughout the city. In fact, one of them is just out here on Stadium in Maine. Those vehicles are being detected, and we're tracking their trajectories. The green ones are the ones that are behaving well. The red ones are the ones that might be involved in a near miss event. So how can we use this information to benefit the city and the populace in Ann Arbor? Henry already alluded to this particular use case. I think this is a particularly powerful video. So obviously we don't like interactions between vehicles and pedestrians. And often, especially in Ann Arbor with a student body here and with the advent of cell phones, they're not always paying attention very well. So this particular scenario has a driver making a right-hand turn, and there'll be a pedestrian crossing. And that is a very difficult pedestrian to see. But we can see it from the passive perception of an intersection, recreate that scene in real time, and then project the trajectories of the two actors and see that they're going to collide and send a warning to the driver. So I don't know if you're going to get the audio, but you'll see a red blinking light there. That's a beep, 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 and the driver knows to look. You see the bus driver kind of look to his right there, and then you see that pedestrian walking in front of the vehicle there. So a potential accident avoided because of the real-time nature of the detection system, or near real-time nature. So again, we can take that information and we can send that information and that warning out to any connected vehicle, like the bus is a connected vehicle. Another impact is it probably doesn't take a lot of imagination to figure out that a whole city is a large network, and there's a lot of infrastructure to manage. So we built a state of health monitoring tool, or smart city infrastructure monitoring here. All the dots on the screen are intersections and roadside units and passive perception. And each green dot is one that's online. The gray dots are managed by MDOT, and I'm pleased to say that we got our permit last week. So those gray dots are being turned into green dots as we speak. The yellow dots are intersections that need a little bit of help. They're offline for whatever reason, so we can dispatch crews to take care of those and do the field work that's necessary to keep them up. So we feel that this is going to be a significant tool set needed by many cities moving forward as these technologies move across the nation and the world. Another impact is, as Henry alluded to, is just the aggregation of data. On your left, you have a red box, which is kind of the stories that were told years prior. They had to rely on city police reports for any kinds of accidents, and that can lead to stories like the one you see there, where we haven't seen anything. This intersection must be behaving nominally, when in truth there could be a lot of near misses. So not only can we see those near misses now, but we can make minor adjustments very cost effectively, and then look at the data afterwards and say, after this quick change, we have 3 months and the data is substantially better. We're getting far fewer near misses. So now I'm going to show you a little bit about the UI, and I'm getting close to the handoff point to Rusheng. So Rusheng, if you're out there listening, get ready. So again, aggregate data. Here we're looking at one of the first screens you see when you pop up the near miss system, and you can see the intersections there are the yellow dots, and there's numbers in there. So we're collecting near misses. This tool allows the city to kind of drill down on an individual intersection and take a look at what's going on. We're going to do that now. So here's my favorite intersection, which is the one right down the street at Main and Stadium. You can kind of see all the events that are happening there. At the very top, we've got a bunch of filtration going on. So over a period of time, we might be looking at a day's worth of data here, or a week's worth of data. That's all up to the user. And then they would pick one particular event, and we're going to take a look at that now. I always start with the recreation because it highlights the vehicles that are involved in the near miss event in red. So I'll play that now. You can see that the two red vehicles, the one's moving north to south, may have been speeding. The one taking the left turns probably maybe done a light violation, and they're kind of crossing late. Here is the same video here. I'm sorry, the video of the same event. And I'm just going to go ahead and play that for time. You can kind of see that vehicle moving south was indeed going quite fast. They had to do some aggressive braking to avoid that collision. Again, no police report here, but our system catches it and puts it in front of the city managers. So with that, I'm going to hand it off to Rusheng now for the architecture of the system, the how it all works.
Okay, hi, everyone. My name is Rusheng Zhang. I'm an assistant research scientist at the Mcity. I'm very glad to have an opportunity here to introduce our newly open source project Mcity, which is a platform behind the near miss detection system that Derek has just talked about. The Mcity is a digital infrastructure platform that transforms the distributed roadside facilities into an integrated intelligence system capable of the roadside perception, abnormality detection, and interacting with the road users as well as the cloud. The Mcity is basically built around two core capabilities. The first one is the roadside perception and prediction. Mcity is equipped with many roadside perception algorithms. It basically supports most of the common roadside installed sensors, such as the facial cameras, regular cameras, and the LiDARs. And it essentially provides a real-time object detection and localization, as well as the multi-object tracking and abnormality detections. Second capability of Mcity is the integration. Mcity essentially connects the distributed roadside devices and facilities, such as the sensors installed at the roadside, V2X radios, the traffic signal box. All of them are normally operating in an isolated way. Mcity is built with the aim to build all this, to leverage all these existing roadside facilities into a unified intelligence system, allowing different sensors and infrastructure components to work together in real time. Okay. Can you go to the next slide? Yeah. So this is a slide showing the Mcity's architecture. Overall, it's an edge cloud architecture. the edge side handles all the real-time functionalities, including the detection, sensor fusion, localization, tracking, trajectory prediction, and also near-miss detection or abnormality detections. And the cloud side focus mainly on the data analytics, the large-scale management, and also extending the connectivity. Basically, what it means is that the cloud can deliver the infrastructure information to the cell phone and in-vehicle infotainment system through the cellular network. And in this way, Mcity will also provide, as you know, it's already open source, and it provides the supporting libraries for the cell phone and IVI systems. For example, it has a library in Android and iOS system, so that it basically provide a practical way for the infrastructure system to communicate with the road users through the cellular network. And during the process, when the V2X communication is growing, we provide another practical way to communicate other than the V2X communication. Can you go to the next slide? So this is when we install the Mcity, we essentially can just install the edge computing device. It automatically connects with all the surrounding devices like the roadside cameras and the V2X communications and cloud and everything. And the only hardware we really need to install on the roadside is this computing and edge computer. And it could be directly on the roadside, or it can be in the same network. As long as it is in the same network with all the other facilities, we will be able to get this whole system working. And can you go to the next slide? And now I want to show some examples of the Mcity's system operating in the real-world deployments. This is an example of the roundabout in Michigan. This is the State and Ellsworth Road roundabout. And we basically installed 4 sensors at the 4 corners of the roundabout. Can you play this video? So on the left-hand side, you can see the 4 fisheye cameras. Each of them sees parts of the roundabout, and we do the detection and then sensor fusion and reconstruct the traffic and show it on the right-hand side. The right-hand side, we show all the vehicles and its trajectories. We also see the trajectory prediction results of its future trajectory, showing as those yellow dots. And go to the next slide. This slide essentially shows the near miss that we have found in, Derek has also talked about that. I just show more cases. This is on the Huron and Plymouth intersection in Ann Arbor. And you can see all these different kinds of near miss. There are like the merging of the left turn vehicle and the right turn vehicle. And there is also left turn vehicle blocking the straight traffic and through traffic. So all these examples are found in real time on the intersection with a high precision of roughly 85%. So that's actually a very high precision. That's higher than most of the existing system, much higher than the existing system currently. So we are not just open source, we are also the top notch in terms of the performance. And can you go to the next slide? And this next one is the one that last year we also participated in the US DOT's Intersection Safety Challenge. This is a challenge hosted by US DOT. They basically have 120 participating teams. All of them are very capable teams. They are from top universities and core players in the industry. All of them come, and US DOT basically offers the sensor data to us. We do process the data, get the perception result, and send back to US DOT. They compare with the ground truths and score each team. And our team is the tier 1 participants, and that's essentially there are only 4 tier 1. That's the highest award. So we basically win this competition. And this video shows one of the sample data. Can you play this video? On the left-hand side is the detection result, and on the right-hand side is the sensor view. One of the sensor view I picked, this basically shows the whole intersection. You can see the vehicle is coming on the left-hand side, and it's about to see in the intersection, and it hits this dummy adult when it's trying to cross the intersection. And can you get back the video a little bit? Let's look at the left-hand side. Can you replay the video, please? No, not this one. Yeah, can you replay? And we can actually look at the left-hand side when you can see that we see all three adults at the roadside, and one of them is dummy, and the system actually knows it's dummy. And when you see the vehicle go through, and it hits the adult automatically immediately disappear because it's already crashed into pieces. So this is a good example of how our detection system works in real time. And can go to I think this is the last slide. We basically already open sourced the Mcity system. This is not just a prototype research script. This is actually an industry level deployment code. It is being validated and updated and fixed through the years of continuous 24/7 deployment in the real world operation. We have carefully designed the code. All this code has been wrapped into atomic functional components so that it's actually flexible and reusable and easy to scale. This allows Mcity to adapt many different roadside configurations and significantly ease the process of large-scale deployment of the roadside intelligent transportation infrastructure. And if you have more questions, you can go to this website. This is our official Mcity website. It has many informations you might need, and you can also scan this QR code for more information. Yeah, thank you very much.
Do we have any questions?
Yeah. So I just wanted clarity. So you're saying the near miss activity. Oh, sorry. Oh, I get to be on a microphone. That's awesome. The near miss activities or the near miss events, are they just between vehicle to vehicle or also vehicle to pedestrian?
Both cases. So vehicle to all vulnerable road users. So
okay.
We have seen cases where there's aggressive braking needed to avoid hitting somebody crossing in the crosswalk. So.
Okay, and you were saying that you've been collecting this data. Who do you give the data to, and what do they do with it?
So the data of the near miss events, that is available to the city of Ann Arbor to make management decisions. And we also store the event data because it's valuable. It can be used to train further algorithms.
Just one quick follow-up on that. So you're doing vehicle to pedestrian. What about to bicycles and scooters?
Yep, those two.
Those also? Okay,
of
perfect.
Course, yep.
Thank you.
All right, I'll yield it back to Greg.
Thanks, Greg. Thanks. All right, sorry to cut off questions. I know there's a lot of exciting. We're going to have a break in a few minutes. Please hit Derek up for more questions. I just want to underscore, we won the Intersection Safety Challenge for USDOT, and we're releasing this to you today to work with us on. Phase 2 of the Intersection Safety Challenge is in our near horizon. If you want to work with us on it, very excited to talk to you. Thanks, Derek. Thank you, Rusheng.